Electrical circuit analysis, B and BTech students. In this video, we see transients response analysis, that is called time domain analysis. First topic is transient response analysis, oral circuit. In this video, we see that is Anna University syllabus, third unit. Man Engineering welcomes you all. In this video, we see complementary function and plus proportional integral, that is total response is obtained at t equal to 0 plus t is equal to infinity. Go to steady state, put at origin pole is introduced. Pole is introduced, that is called step input. Oral circuit shown in figure, that is t equal to 0, I of t current V minus 2 plus source L inductance or. Common equations, previous classes we know, or I of t plus L dI of t divided by dt is equal to V of t. Solution, response I of t, that is equal to complementary function plus potential integral, that is CF plus P dot I. Total response is transients plus steady state response. Transient response is obtained from complementary function at t equal to 0. Steady state is obtained from t is equal to infinity. That is, steady state is detecting no error and pole is introduced to at origin. Go to steady state at t is infinity time. The tabulations is used in this circuit. Inductance is changed into t is equal to 0 or 0 plus open circuit. Equivalent circuit at t is equal to infinity, that is steady state, that is inductance is changed into short circuit. Previous classes I given that tabulations of transients response for t is equal to 0 or 0 plus or t is equal to infinity. Total response is equal to transient plus steady state. I already explained in previous classes, transients is obtained with CF, steady state is obtained with PA. CF complementary function is or plus LD into I, obtained from first equations. That is or I of t plus L dI of t divided by dt V of t. V of t put take derivative or plus LD is equal to 0. D is minus or divided by L. That is exponential function mathematical formula use capital A e power minus or divided by LT. That is, we obtain transient response analysis. At steady state t is equal to infinity. Circuit shown in figure. Inductance is short circuit. Tabulations given. Or resistance is present. V of t and I of infinity is find out. I of infinity is find out from PA, that is I of t infinity is equal to I infinity, that is V divided by R. Only resistance and voltage present, so our current is V divided by R using Ohm's law. SS is steady state, that is steady state response. The total response of I of t is I of t transient plus I of t steady state. I of t is equal to transient response is, that is complementary function A e power minus R divided by LT plus steady state response V divided by R, that is total response transient response analysis for oral circuit. We obtained that formally. Man Engineering, thank you. That is Anna University syllabus third NA.